we move on to the problem. Take down this problem for solving using a Gauss-Seidel method. Problem number 1. The relevant per unit admittance are indicated on a diagram, and the bus data is in the table below. Okay, so what they will give is they are giving the 3-bus system. Generally, they will give 3-bus system because it will be very easy for you to. If it is more than bus, approximately 4 bus they may give in your examination. Up to 4 bus they may give because calculation will take more time. So generally they may give 3 bus or 2 bus or up to 4 bus means some it will take somewhat time. Okay, so maximum they will ask 3 bus only. Sometimes okay, your thing then they ask 4 bus also. The thing is that you need to do the solve the problem very fast because time allotted for you to solve this problem is only 20-25 minutes, maximum 25 minutes for solving the problem in exam center. So if you take more than that, so again you have to rush up more and you lose the marks. Okay, so here there are 2 generator buses are there. So here 1, 2, and 3 buses are there. The admittance between 1 and 2 is minus J3. Okay, next admittance between 1 and 3 is Y13 is minus J4. So admittance between 2 and 3 is minus J5. Okay, the relevant per unit line admittance are indicated on the diagram, and the bus data. Okay, bus data also they are given in the table. Okay, so they will give like this: bus number, type of the bus, generation data, PG, QG, load data, PL, QL, bus voltage, V and delta. So first bus, slack bus. Slack bus, you know, what are the quantities that is mentioned in the slack bus is voltage and phase angle, delta. Okay, voltage and phase angle. So voltage they have given us 1.02, delta they have given us 0. And this bus, this values, that is P and Q values of P and Q values, we need to calculate. Okay, next PQ bus, there are 2 PQ buses in this problem. PQ bus, second bus is PQ bus. In that PQ bus, P and Q are mentioned. Generation type, generation side, real power and reactive power is mentioned. 0.25 is mentioned generator bus, and QG is reactive power at the generation bus, generation side, 0.15. Next is load bus. In the load bus, real power is 0.5. Reactive power in the load bus is 0.25. That is in the second bus. So this voltage and delta values, voltage and phase angle values, we need to calculate. Next, third bus, PQ bus. Here, what are the things they mention? P and Q mention. Okay, P and Q they have given as 0, 0. Generation they have given as 0, 0. The load bus, okay, they have given the value as PL is equal to 0.6, QL is equal to 0.3. Okay, real power, reactive power, and this bus voltage, that is V and delta voltage and phase angle, we need to calculate. So what they did, determine the voltage at buses 2 and 3 after first iteration using the Gauss-Seidel method. Okay, take the acceleration factor as 1.6. So like this, if the question is asked, very, very simple. Okay, your everything is given. Okay, easily you can solve because they have given iteration also. They have given what are the things to calculate, determine the voltage at buses 2 and 3 after first up to first iteration. After first iteration using the Gauss-Seidel method, and also take the acceleration factors 1.6. In some problems, this acceleration factors will not be mentioned. So as I said, you need to assume the acceleration factor as 1.6. In some problems, voltage flat start will not be given. In some problems, flat start, assume the flat start, like that only given. If it is not given also, it is default. You need to start with the flat start. That you need to remember. Sometimes the values will be given. sometimes values will not be given. Okay, so you don't worry. Okay, don't worry why the values isn't given. The problem is wrong. We can get full marks for this problem. Don't think like that. Okay, so whatever the values given means happily you can take. If it is not given means default you take it as 1. Okay, so that you need to remember while solving the problem. These are the some of the key points you need to remember while solving the problem. What you need to calculate, that also very, very important. So here it is clearly given, determine voltages at the buses 2 and 3 after first iteration by using Gauss-Seidel method, and with this alpha values clearly given. Sometimes they will not give this method also, just they will ask to calculate the voltage and voltage, determine the voltage and change in the voltage, like that blankly they will give. Okay, so that you need to correctly choose the method, and that's sometimes the values will not be given. Real power and real power, reactive power for the certain generation bus will not be given. So you take it as 0, like that. Okay, so sometimes I'm saying the hard cases. So now we'll move on to the problem. What is the first step? We need to calculate the Ybus. We need to formulate the Ybus. So Ybus, you know, 3 buses are there. So here it will come Y11, Y12, Y13, Y21, Y22, Y23, Y31, Y32, and Y33. How to calculate this Ybus? Already we have seen in detail how to formulate this Ybus in our previous classes. If not, go back to my previous classes and try to down this. Okay, so just a fast glimpse of this one. What is Y11? Is nothing but here. How to calculate Y11? Here Y12 plus Y13. Y12 plus Y13. Sometimes here self admittance also will be given. Self admittance, that also you have to very, very careful. Okay, so here they will give self admittance as Y11 is equal to some values, some 3J, something 4J, like that. Okay, 2J, something like that they will give it. Okay, so in that case, that value also you need to take. So now self-admittance is not given. So only the 2 values are given. Okay, so Y12 plus Y13, that's all. Y11 is nothing but Y12 plus Y13. So simplifying, you'll get the answer like this. Substitute the value of this, and minus 3J minus 4J, that is minus 7J. Similarly, Y22. Y22 what? So here, Y22, Y12 plus Y23. That's all. So minus 3J minus 5J. That is the answer. That is minus 8J is the answer. Minus 8J is the answer. Next, Y33. Similarly, Y33. How to calculate Y33? Yeah. 2 things you need to add. Y13 plus Y23 minus 4J minus 5 minus 9J. 3 you calculate. Similarly, rest all the things. Minus of that particular Y12. Y12 what? Yeah, Y12 is here. Y12 is minus 3J. Okay, so minus 3J. Y13 is minus 4J. Y23 is minus 5J. So similarly, what you need to do is you need to substitute over here. So here minus of. So minus of minus 3J is 3J. So similarly, minus of minus 4J is 4J, like that. So here also this and this values are same. Here minus of minus 5J is 5J. Minus of minus 4J is 4J. Here also minus of minus 5J is 5J. So here this values we already calculated. Just substitute it. So now we formulated Ybus matrix very easily. Okay, don't take much time. Okay, so if you skip this step directly also you calculate, but don't skip, because sometimes if you miss this minus plus, you change entire problem will go wrong. Okay, so that's why this alone you just calculate it fast and try to okay, fill this Ybus matrix. So now we frame the Ybus matrix. Next step. What is that? Next step, how to calculate the real power? Real power P2 is equal to P2G minus P2L. This also we already see. P is equal to PG minus PL. Okay, generation minus this PL is nothing but this line. Okay, generation minus this line. Okay, that particular line or load. Okay, generation minus load. Okay, so here P2G is 0.25, P2L is 0.5. How to take this P2G? You need to go to the problem. Okay, P2G is this value generation at the second bus. So this is 0.25. Okay, load bus. What is the second bus? Load is 0.5. Okay, so PG minus PL. Because this is 2G, P2G minus P2L, because this is the second bus. So 0.25 minus 0.5. Okay, 0.25 minus 0.5. It is minus 0.25. So P2 we calculated. Next, what is the reactive power? Reactive power Q2 is equal to same formula, QG minus QL. So Q2G minus Q2L. Where to take this? From the prod. From the prod. If it is not given, means you take that value as 0. Okay, so problem clearly given. Second bus QG is equal to 0.15, QL 0.25. For second bus, this is the values. Just minus this 0.15 minus 0.25. 0.15 minus 0.25. So Q2 is equal to minus 0.1. Okay, so this 2 we calculated. Next, what is the next step? Similarly, P3 and Q3. Same formula, P3G minus P3L. So what is P3G value? P3G value is given from the problem. P3G value given from the problem 0, and here also the load bus it is given as 0.6. If it is not given, as I said, you take as 0. Okay, so in the third value 0 minus 0.6 minus 0.6. Similarly, Q3 is equal to Q3G minus Q3L. So Q3L is given as 0.3 from the prod. Okay, so here you simplify minus 0.3. Next, bus number 1. Bus number 1 is slack bus. Slack bus, what is mentioned? Clearly mentioned. Okay, clearly mentioned. V1 not. Okay, you take V1 not. V1 not means like zero, like first thing. Okay, V1 not is the first initial values. You take it as initial value. So V1 not initial values is given as 1.02 at the angle of 0 degree. This how we are taken this 1.02 at the angle of 0 degree from the problem. From the problem, that is first bus, slack bus 1.02 and 0. And second bus, this voltage and delta value not given. So we are assuming the flat start. That is 1 at the angle of 0 degree. Here also 1 at the angle of 0 degree. So we are assuming that full voltage is there at the particular bus, like that. That meaning is, default meaning is that is the full voltage is available at the particular bus. So here we are taking the V1 naught, that is initial value as 1.02 at the angle of 0 degree, and the next second bus V2 naught, that is initial value that we are taking as 1 at the angle of 0 degree, and V3 naught, that initial value 1 at the angle of 0 degrees. Next, set to the iteration count. First, we are starting the iteration count. K is equal to 0, P is equal to 2, and Q is equal to 1. So we are starting the iteration count. K is equal to 0, P is equal to 2. What is this P? P is nothing but bus number. Okay, P is nothing but the bus number that we are starting from 2. Why we are starting from the 2? Because already first bus, say for example, P is equal to 1. That is the meaning that first bus voltage values already given in the problem. Okay, voltage values already given in the problem. That is 1.02 at the angle of 0 degree. So now no doubt. Okay, here P is equal to 2 and Q is equal to 1. Q is equal to 1. So this is the formula we have seen from the algorithm. That is VP K plus 1 is equal to 1 divided by YPP into PP minus J into QP divided by DPK star minus summation Q is equal to 1, P minus 1. Next to YPQ, VQ K plus 1 minus summation Q is equal to P plus 1 up to N, YPQ, VQ, K. just substituting this all this value. Okay, iteration count k is equal to 0, p is equal to 2, and q is equal to 1. Just to substitute this. So if you substitute p is equal to 2, then it is sorry, here k is equal to 0. p2 of k is 0. 0 plus 1 is 1. So here 1 divided by y. pp is 2, 2. Okay, next p2 minus j into qp is 2 divided by v2 of 0. Okay, star. What is star here? That is minus. Okay, so 1 minus j0. Already we have seen in the previous class. If you not understand this, we go back to my previous class and we already discussed formulation of load static load flow equation. Okay, or power flow equation that we already see this particular thing. V2 not star is nothing but star is nothing but angle alone will be in the negative. Okay, angle alone will be in the negative. That is 1 minus j into 0. Okay, so here minus summation q is equal to 1 to 1. Here p is equal to 2. 2 minus 1 is 1. So like that also you can take, and directly 1 also you can take. Next y of pq 2 1. Next b q is 1. Okay, k plus 1 is 1 because k is equal to 0. So 1 minus summation q is equal to p plus 1 is 3. 3 up to n. Okay, so here y n is means up to number of buses. Okay, so here it is n is 3, so q is equal to 3. That's all. Okay, so if q is 2 up to n, you need to take. Okay, but here it is only 3, so n is also 3, so no need of taking because q is equal to 3. Okay, next y pq 2 3 b 3 of 0. Next, just a substitution. Okay, what is p2? That is from the problem. P2 is minus 0.25. That is P2. Yeah, P2 is minus, P2 is 0.25. Okay, so here just a substitution. Okay, P2 is 0.25. So here minus. Okay, so here we have taken as a minus here and plus here. You can directly substitute, no issues. And also here y22, what is the value for this y22? Yeah, y22 is this one, minus 8j. So here we have taken as minus 8j. Minus 8j. So here minus of q2. What is q2? Sorry, p2 here. Sorry. So p2, you need to take the value here. Okay, p2 already we calculated now, minus 0.25. So that only we have taken, not from the problem, because that is generation. Okay, this is P2 real power that we already calculated. Okay, don't take from the problem because that is from the generation value. This is the P2. So P2 is minus 0.25. So here we are just substituting P2 minus 0.2 Q2. Q2 also already we calculated. That is minus 0.1. Yeah, minus 0.1. Similarly, P3 minus 0.6, Q3 minus 0.3. Just substituting here, all the values here, divided by V2 not star. So already I said 1 at the 1 minus 0 J, or 1 at the angle of minus 0 degree. Okay, minus here y21. Y21, what is the y21? Y21 or y12? Okay, y21 here 3J. That you need to take 3J into V1 dash. V1 dash what? Yeah, here V1 dash. So, okay, V1 dash or initial value. So V1 dash is 1.02. 1.02 at the angle of 0 degree. 1.02 at the angle of 0 degree. Okay, minus Y23. Y23. What is Y23? Yeah, here 2, 3, 5G. Okay, here you need to substitute 5J into V3 naught. V3 naught. Okay, so V3 naught is nothing but 1 at the angle of 0 degree. That's all. Take your scientific calculator and you just calculate it. Just type it easily in a one single step. You will get the answer. Okay, so here what you can do is you can calculate the value. Okay, so while solving you will get the V2 dash as 0.995 minus 0.03125 J. And as I said before, after decimal, always take 5 values or 4 values. Okay, better you take. So because here 0 is coming now. So here you can take some values 0, 3, 1, 2, 5 like that. So here we have taken as 5 values. So why? Because here 0 is coming. Okay, better 4 is enough. But I think in calculator, so you just make a comment in the comment section. You just put a comment. Um, what value you got in your calculator, because this is the value I got in my calculator, in my scientific calculator. So I think similar values, don't round it off anything. Okay, so here don't round it off anything. 0.25 instead of 0.25, you just take 0.2, then you'll get more variation here, and answer also will be get more variation, and marks also they will reduce like okay, so whatever the value they have given, 0. Say for example here 0.2524 like that they have given, you take as it is, don't round it up. So now we got the value as V2 dash equal to 0.995 minus 0.03125 J. Next, similarly, what we need to do, we need to calculate the change in the voltage or new values. Okay, so new value del Vp K is equal to del Vp K plus 1 minus del V K. Okay, just substitute K is equal to 0 here. Del V2 dash V2 1 is equal to V2 1 minus V2 0. Okay, so here V2 1, V2 1. Okay, this already we calculated. This same value you need to substitute here minus V2 0. V2 0 that we know, that is 1 plus J0. Okay, flat start. Okay, just use solve using you just calculate using your scientific calculator. You'll get the answer as minus 0.005 minus 0.03125 J. This is the change in the voltage. Okay, change in the voltage. Next, accelerated value, new value. New value is equal to accelerated value, old value plus alpha into Vpk plus 1 minus, okay, Vpk. Okay, so this is the del Vpk. One more step is that del Vpk, change in the del Vpk. Okay, so this already we calculated. This already we calculated. This del Vpk. Okay, this already we same answer. You can take it over here. Okay, or otherwise you skip this step and here you can calculate and you can write. But the better thing is that you calculate this. You just substitute here. Whatever the answer is coming, you just substitute here. That's all. So Vp 2 dash accelerated or new value is equal to V2 0. That is old value plus 1.6 into V2 dash minus V2 0. That is initial value. Okay, so here V2 not 0 is 1. That is initial value is 1 plus 1.6 acceleration factor into this particular V2 dash. V2 dash where? Okay, so not V2 dash. We already calculated this whole thing. This answer just like that you take here. Just you will get the V2 accelerated value. Okay, V2 dash accelerated value or new value you will get. Next, what is the change in the voltage? How to calculate the change in the voltage? Change in the voltage del Vpk is equal to del Vpk K plus 1 minus Vpk. Okay, so here you are calculating for third bus. Third bus you are calculating. Okay, so similarly, you need to calculate Vp K plus 1 for the third bus also. Okay, third, I think second bus we calculated, no? Yeah, second bus we calculated, no? The same formula, you take this as your homework. So V3, here, same formula, you need to substitute P is equal to 3. Okay, 3. So V3, 1 is equal to 1 divided by Y 3. So here P3 minus Q3, here V3 not star minus summation Q is equal to 1 to 1 to 1. And here V31 D1 dash like that. Okay, summation Q is equal to 3 here Y33. So same thing V3 you need to calculate. Okay, so here where so here V3 not V3 1 you need to calculate. So while calculating, you will get the answer as 0.975 minus 0.067 J. Okay, so you also, those who are watching, you also make a comment whether you got the same answer for you or not. Okay, don't round it off. The same thing I have taken. Whatever the answer came in my scientific calculator, same thing I have taken here. Next, V3 not, that value you know, flat start 1 plus J 0. Okay, just okay, simplifying this, you will get the answer like minus 0.025 minus 0.067 J. Next, acceleration factor, we are taking this 1.6. Next, VP accelerated value or new value. VP new K plus 1 is equal to VP K plus alpha into del VP K. Okay, so del VP K already we calculated here. So with that value, you need to just substitute V3 0 is 1 plus 1.6 into this particular value that you are kind of simplifying. You'll get that answer as that is V3 accelerated 1 is equal to 0.96 minus 0.10720. This is the answer I got. Okay, so the answer, the formulation is very, very simple. So here you see what they have asked. So we have calculated what? Now we have calculated this voltage at a particular bus, that is second bus. Okay, change in the voltage, that's a new value, that is accelerated value, new value in that particular bus, that is second bus. And similarly here also, voltage, that particular voltage and this voltage, that is VPK plus 1, V3 1, that value voltage we have calculated, and the same thing, accelerated here, the change in the voltage, okay, change in the voltage, that also being calculated, and the accelerated value, okay, del V3 and accelerated value, that is V3 1, that also be calculated. So that only asked to calculate in the problem. They have asked to calculate the voltage at the second and third bus. Okay, determine the voltage at second and the third bus, and after the first, by using the first iteration. They said to calculate first iteration. Say for example, if they ask to go for second iteration, this is of 10 mark problem. In some universities for 16 marks, they might ask for second iteration also, but very, very rare case. But sometimes if they ask, you need to go for second iteration. Second iteration what? So here K is equal to 0, you substituted, no? So instead of K is equal to 0, you need to go for K is equal to 1. Okay, so now again you need to increment by 1. The same thing you need to calculate. Second iteration also you need to calculate. So if you calculate the and compare with the first iteration, second iteration, if first iteration value and second iteration value is not changing much, you can stop the problem there and you can display the answer. You can write down the answer. If it is there is a much changes, again you need to go for the third iteration. So that's why we are going for the programming. If you program this algorithm, then if you just give the number of iteration as 3 or 5 or 10, like that, simply within some seconds or minutes, within 1 minute or within some second, you will get within some milliseconds or within some nanoseconds, you will get the answer. If you program in such a way, you can easily get the answer. Okay, no need of waiting. If you do with pen and paper only, it will take more time. Okay, but mostly they may ask to go with the only one iteration only. So if you want, you take down the problem as homework, and you can calculate for second iteration also. Second iteration also, you can just compare it, because once you make the second iteration with the pen and paper, then you can easily understand the problem. Okay, how the values are changing. Okay, how the values are changing. So what is the change in, say, for example, V2 1. Okay, so V2 2, same thing, V2 2. Then what is the value? So if it is more changes is there, you need to continue again. Or otherwise, you simply stop the value. So I think almost you will get the same answer only if you go for next iteration also, you may get 0.999 minus 0.3125. Instead, you will get 0.15 like that. So the phase angle also, but you need to get here 1 minus 0j. That you need to get. But due to some change in the values, due to some losses, distance, due to the distance between the buses, change in the losses, you are getting the value like this. But actually speaking, you need to get 1 here. 1 minus 0j is the thing. So while verifying the answer also, you may verify like this. If your answer is some 2.34 minus some 3.45j, then your answer is wrong. It should be near to 1. This real value is near to 1. This angle value should be near to 0. Then your answer is correct. And don't round it off. As I said, don't round it off. Take after decimal, you take 4 digits or 5 digits or whatever the value coming in the problem. Okay, so while solving, while explaining, we took more time. But you practice and you practice in your home, you practice in your colleges, you will solve in more time. Okay, for hardly it will take only 20 minutes, 15 minutes to 20 minutes for solving this problem. If you do very fast, and your fingers has to play with your scientific calculator, then only you can solve within 15 to 20 minutes. Then you slowly type and slowly do, then it might take more minutes also. But for this problem, maximum time is 15 to 20 minutes. That's all.